All right, let's dive right in. If you're a senior architect, you already know that building a data platform is one thing, but building one that actually powers and accelerates machine learning, that's a whole different ballgame. So over the next few minutes, we're going to lay out a practical blueprint for doing exactly that on Azure. Let's get to it. So here's a critical question you have to ask yourself. Is your current data platform a launchpad for AI innovation? Or, if we're being honest, is it more of an obstacle? A maze of silos and manual processes that are just holding your data science teams back. The answer really determines if you're building for the future or kind of being held captive by the past. And this slide really shows the two realities we see out there. Over on the left, you've got that traditional siloed approach. This is where data engineering and data science are basically living in separate worlds. And the result? It's slow, it's manual, and worst of all, it's inconsistent. But on the right, that's our goal. A truly integrated platform where machine learning is just a natural, seamless extension of your data workflow. That's what makes it fast, automated, and reproducible. To get to that goal on the right, we've got to start with a bit of a mindset shift. We're not just storing data anymore. We're actively, purposefully preparing it for intelligence. It's all about building a foundation that anticipates what machine learning is going to need, right from day one. This is the guiding principle for our whole architecture: unification. The main goal is to just tear down that wall between the data teams curating the data sets and the ML teams who are trying to train models. Because when one process flows seamlessly into the next, that's when you unlock some serious speed and innovation. Okay, so this brings us to the first big piece of our blueprint, what I like to call the data curation factory. It's about changing how you think. Stop seeing data prep as just a bunch of one-off, tedious tasks. Instead, start seeing it as this super efficient assembly line, turning raw, messy data into a finished product that's ready for AI. And this assembly line has 4 key stages. First, we ingest the raw data. So for a demand forecasting model, that might be raw sales transaction logs. Next, we refine it through what we call bronze and silver layers. That's where we clean it up, get rid of duplicates, and give it some structure. Then we enrich it. Maybe we join it with external data, like weather patterns or upcoming holiday schedules. And the final output? That's our gold data set. It's a curated, aggregated, totally trustworthy asset that's ready for some serious analysis. Now, this factory doesn't run on its own. It's powered by 3 core Azure services. Think of Azure Data Lake Storage as our central warehouse for everything, from the raw stuff to the finished gold data. Then, you've got the powerful compute engines of Azure Databricks for all the complex transformations and data science, working right alongside Azure Synapse Analytics for large-scale data warehousing and SQL analytics. These are the tools that do all the heavy lifting for us. So, our data is now beautifully curated. But how do we connect it efficiently to our machine learning workflows? Well, this requires a special kind of bridge. And that bridge is the feature store. Honestly, this is one of the most critical, game-changing components in any modern ML platform. So what exactly is it? A feature store is basically a central library. It's a managed place for all your pre-calculated data variables, your features, all ready to be used by your models. It completely solves that classic problem of every single data scientist having to recreate the same features over and over and over again. And this quote really gets to the heart of the philosophy here. Define a feature once, use it everywhere. Think about that. For our demand forecast, maybe we have a feature called weekly_promotional_discount. With a feature store, you engineer it one time, get it perfect, and then it's instantly available for any model, whether you're training it or using it for real-time predictions. That's how you get absolute consistency. The difference it makes is just night and day. Before, you've got data scientists wasting tons of time rebuilding features, which leads to all kinds of inconsistencies between your training data and what's happening in production. But with a feature store, you get reusable assets, you get guaranteed consistency, and you get a massive boost in team collaboration and just overall speed. Look, having an automated factory is fantastic, but if you don't have quality control and trust, it's pretty much useless. For any serious enterprise-grade ML platform, governance can't be an afterthought. It has to be woven right into the fabric of the architecture itself. First up is data quality. It sounds simple, but it's this profound idea that your data is correct and actually fit for what you want to do with it. In our demand forecasting example, it all comes down to asking, are we absolutely positive these sales numbers are clean and accurate? Because if they're not, our model's predictions are just built on a house of cards. They become meaningless. Next up is data lineage. You can think of this as your data's audit trail. It gives you the power to trace every single piece of data from its source all the way to a final model prediction. So when a forecast looks a little weird, lineage is what lets you ask, wait a minute, where exactly did this weather data come from? And then you can debug the entire pipeline way more efficiently. And finally, we have reproducibility. This is the absolute cornerstone of any professional MLOps practice. It's the ability to perfectly recreate a specific model or a prediction from the past. For compliance, for debugging, for just basic scientific rigor, you have to be able to say yes to the question, can we get that exact same Q4 forecast again if we needed to? It's non-negotiable. Okay, we've covered the factory, the bridge, and the governance layer. Now, let's put all of these pieces together into our final unified architectural blueprint. Let's build this blueprint from the ground up, step by step. Everything, and I mean everything, starts with the foundation, a single centralized Azure data lake. This is what holds all of our data, from raw to curated, and it establishes our single source of truth. Now, on top of that storage foundation, we're going to layer our powerful analytics engine. This is where Databricks and Synapse work together to run our data curation factory, transforming and prepping all that data at scale. And for the final step, we add the Azure Machine Learning service on top. The real architectural magic here is how it connects so seamlessly to the analytics engine through that feature store. That's the connection that makes all our curated data instantly and consistently available for model training, deployment, and monitoring. And this table really brings it all home. It traces our demand forecast example right through the architecture. You can clearly see how raw data gets ingested into the data lake, then curated by Databricks, engineered into features that live in the feature store, and finally used by Azure ML to train a model. It's a perfect, beautiful end-to-end flow. So let's just quickly recap the big architectural takeaways here. Number 1, always prioritize a unified platform over disconnected silos. Number 2, implement a feature store. It is the essential bridge between your data world and your ML world. And number 3, embed governance, quality, lineage, and reproducibility right from the start. Do not treat it as an afterthought. By following this blueprint, you're not just building another data platform. You're actually building an AI factory, one that's capable of producing real, tangible business value at scale. So the only question left is, what are you going to create first?